Hello everyone, welcome to Royal Palace online classes. So today let us discuss the synopsis of moving charges and magnetism. First, I will discuss the force on a charged particle. Force on a charged particle in a magnetic field. Force on a charged particle in magnetic field. First, suppose there is a magnetic field of magnetic field strength B. Consider a magnetic field of magnetic field strength B. A charged particle of charge Q is projected with velocity into this magnetic field. Then this charged particle experiences a force F is equal to QVB sin theta. If you write in vector form, F bar is equal to Q into V bar cross V bar. Q into V bar cross V bar. This is the force. The charged particle, when enters into the magnetic field, after entering, it revolves in a circle of radius r. And B and B, it is perpendicular distance, so perpendicular, then force F is equal to, will get QEB, then mv square by r is equal to QEB. The force due to magnetism will provide the necessary centripetal force. Therefore, mv square by r is equal to QEB. V square and V will get cancelled. Then R is equal to mv by qb. R is equal to mv by qb. This mv is nothing but momentum. Therefore, R is equal to Q by qb. By using your first year formula, P square by 2m is equal to kinetic energy. Then P is equal to root of 2m k. Therefore, R is equal to root of 2m k by qb. Root of 2m k by qb. Next, if you, instead of providing kinetic energy, if you give only electric field, kinetic energy can be written as Q into potential difference. That we can substitute here. R is equal to under root of 2m Q into potential difference by QV. This is the formula for radius. Instead of projecting it at 90 degrees, suppose if you project it at certain angle theta, project it at certain angle theta, what happens is this charged particle will revolve in a circle and moves forward. It moves in a spiral path or helical path. Helical path. It travels helical path. Helical path. Then, in that case, radius is equal to mv sin theta by qb. Radius is equal to mv sin theta by qb. Here, v sin theta helps for providing. V sin theta provides centripetal force. Provides centripetal force. Centripetal force. Whereas V cos theta responsible for horizontal displacement. Therefore, the distance between two helix, this is one helix, another helix, the distance between two helix, you observe this helical path like this. This is one helix, this is another helix. This distance is called pitch of helix. So formula for pitch of the helix is pitch of helix is equal to V cos theta into time period. So we can calculate time period also by using the formula of radius. We take the formula of radius, we can find time period also. Time taken is distance here, distance travelled. It revolves in a circle. So it is revolving in a circle. So time taken I can take distance travelled is 2 pi r by velocity, speed, magnitude of velocity I will take it as speed. So r is equal to, mv by qb, then 2 pi into mv by qb into v. So what happens here? V will get cancelled and time period is equal to 2 pi m by qb. 2 pi m by qb. This is time taken. If you want frequency n, or you can write it as f. Frequency is equal to 1 by time period qb by 2 pi m. Therefore, this frequency is also called cyclotron frequency. This frequency is also called cyclotron frequency. This frequency is also called cyclotron frequency. What is cyclotron? Cyclotron is a device. Cyclotron is a device which is used to accelerate the charged particles. So, how to accelerate the charged particles? How it accelerates and what is the description of cyclotron? Cyclotron consists of two hemispherical structures, hollow hemispherical structures called as discs. They are hollow hemispherical structures called as discs with a certain gap in between them. And these are connected to a alternating source of current. The detailed description of cyclotron and how it works, how it looks like, I already shown in one video. You can refer to the theory video. It is totally a theory topic. You can refer to the theory video. Cyclotron, I have shown it how it looks like, what happens. In this, what we do? Here we should know only the principle of cyclotron. In this, I will project a charged particle, and above this above top and bottom, there will be two magnets which will provide sharp magnetic field. It will provide sharp magnetic field. Okay, above and below. Now, if you set a charged particle into this cyclotron, what happens? It will revolve in a circle. But here the condition what it will do, there is one method to increase the radius of the cyclotron, increase the radius of the revolving particle. What it will do? First, one of the D is maintained positive charge, another D is maintained negative charge. So this charge particle enters into the D and completes one circle. But first it completes one circuit, then it comes out of the D. When it comes out of the D, this charged particle is pushed forward. It is pushed forward, instead of entering into same orbit, it enters into another orbit. Once it enters the gap again, it completes, enters the gap, then it is pushed forward. It completes, enters the gap, pushed forward. Then again it enters into another orbit. This cycle will continue like this. This cycle will continue like this. Then radius increases every time, but time period remains same. Time period is independent of radius. and time period is independent of speed. Time period is independent of speed. So when radius increases, what happens to kinetic energy? Kinetic energy increases. So high accelerated charged particles can be made. You can increase the speed. If you increase the radius, r is proportional to v. Speed increases. When speed increases, kinetic energy also increases. We can find formula for kinetic energy also. Kinetic energy is equal to half mv square. Half mv square. Then v is equal to, you can write in terms of radius formula. R is equal to mv by qb. V is equal to, you can write qb r by m. Half into m into qb r by m whole square. That is half into m into q square v square r square by m square. Square and m will get cancelled. So q square v square r square by m. So if you increase radius, kinetic energy increases. So when kinetic energy increases, these accelerated charged particles are developed and they are used in nuclear reactions. We can use them in nuclear reactions. Nuclear bombardment. This charged particle is immediately released from that chamber. Everything will be enclosed in a wooden case or in a plastic case is enclosed. This is a device. So once the kinetic energy increases, we will open the outlet and this charged particle is utilized for the bombardment, like alpha particle bombarding uranium nucleus. That alpha particle will send into this cyclotron, radius will increase, kinetic energy increases, and finally we can let out that cyclotron. It goes and here the uranium nucleus will be there, then it will bombard. Because to avoid that nuclear repulsions, high kinetic energy particles are required. That high kinetic energy particles are developed from cyclotron. Okay. That's why we call this frequency as cyclotron frequency. This frequency as cyclotron frequency. So here, what formulas you have to remember in motion of a charged particle in magnetic field is first radius. Before that, you have to remember the force acting. And next you can remember the radius. Radius r is equal to mv by qb. Then from radius mv you can eliminate and you can write it as momentum by qb. And next momentum you can write it as under root of 2m ke by qb. And one more formula, K you can replace it by Q into V, where here V is not the speed of the particle, V is the potential difference. So this is about motion of the charged particle in magnetic field. And if next you can study motion of the charged particle in both magnetic field and electric field. Next is motion of the charged particle in both magnetic field as well as in electric field. Motion of the charged particle in both magnetic field as well as in electric field. Motion of the charged particle both in magnetic field and in electric field. Magnetic field and electric field. Suppose in both magnetic field and electric field are produced and we send a charged particle. Let us take I said that there is a magnetic field D. Okay. And I create charged particle will experience two forces. One is force due to magnetism and force due to electricity. Force due to magnetism is QEB sin theta. Here it is, theta is 90 plus force due to electricity is Q into E. But this is a vector addition. This is a vector addition. And we should know in what direction force due to magnetism will act. For that you can use the principle of vector product, or you can take left hand rule. Actually left hand rule will study to calculate force acting on a conductor. That you can take it as a, for this also you can use. If you use vector product, field is inside. This is B. This is B. This is V. This is B. This is V. Right? The condition is V bar cross V bar. F is equal to Q into V bar cross V bar. You have to rotate a screw. You have to rotate a screw in the direction of. You have to rotate the screw in the direction. You have to keep one screw perpendicular to V and B. You have to rotate a screw in the direction of cross product. V bar cross V bar. V bar. This is V. This is V. V bar cross V bar equal to. This is in this direction. Or you can take left hand, forefinger towards field. It is easy to use left hand rule. Forefinger towards field. Forefinger is towards field. Okay. And middle finger or central finger towards current. Current means movement of positive charge. Current is the direction of current is taken as the direction in which positive charge is. That means indirectly it is direction of velocity. Direction of velocity. Next, thumb gives the motion of the charged particle or force acting on the charged particle. Thumb gives the motion of the charged particle. Thumb gives the motion of charged particle. Motion of charged particle, that is force. On which direction the force will act. Okay. So now in this case, this is the case here. B is perpendicular to E. B is perpendicular to E. B and E are perpendicular and perpendicular to velocity. B is perpendicular to E, perpendicular to velocity. Now let us see what are the direction of forces. Now calculate the direction of forces here. Field inside, velocity upwards, it experiences a force in this direction. It experiences a force in this direction. Force due to magnetism will be in this direction. You can observe here. Force due to magnetism is in this direction. And you have to create electric field perpendicular to this. That means electric field I will create in this direction. Perpendicular to velocity. I will create electric field in this direction. Now what happens? Positive charge will always move in the direction of electric field. So FB and FP are opposite. FB minus FP is equal to net force. There is a condition so that if I change the velocity and adjust the electric field, I can get a condition where net force is equal to 0. I can get a condition where net force is equal to 0. In that case, I can get FP is equal to FP. Force due to magnetism is equal to force due to electricity. That is QAB is equal to Q into E. Then Q will get cancelled. Then V is equal to E by B. And this velocity is called velocity selector. This velocity is called velocity selector. The charged particle will be undeviated in this case. Similarly, for light velocity, we take C is equal to E naught by D naught. E naught is equal to C B naught. This is the condition. E naught is equal to C B naught. Understood? This is the situation. Motion of the charged particle. So if they are not perpendicular, if they are parallel, suppose if B is parallel to B is parallel to B, then take one more condition. B is parallel to B, perpendicular to E, or parallel to E. B is parallel to B is parallel to E. In this case, what is the force acting? When B is parallel to E, force due to magnetism will be 0. Force due to magnetism will be 0. And force due to electricity to E, force due to electricity will be to E. Then only one force act on the charged particle. This is force due to electricity. So net force when both electric field and magnetic field are there, Fp bar plus Fe bar, or Q into V bar cross V bar plus Q into E bar. So this is the condition of charged particle when it is moving in combined electric field and magnetic field. This is about the motion of charged particle in a magnetic field. And the next after this, you should know about Biot-Savart law. Before that, let us see how they will ask questions in this motion of a charged particle in magnetic field. Suppose you may ask question like this: a proton, a deuteron, and a alpha particle. A proton, a deuteron, and a alpha particle are projected into a magnetic field. A proton, deuteron, and alpha particle projected in a magnetic field with the same momentum. With the same momentum. A proton, a deuteron, a proton, a deuteron, project and a alpha particle projected into a magnetic field of same magnetic field with the same momentum. Which one of the following may have highest radius? Which one of the following? Which of the following among these three which can have highest radius? This is the question. For that, what I have to use the formula of radius. R is equal to mv by qb. Here is telling that they are projected with same momentum. So this you convert into momentum. R is equal to p by qb. Then momentum is same. So R1 is to R2 is to R3. You want to find which one is more. So R is inversely proportional to charge. R is inversely proportional to charge. If R is inversely proportional to charge, it is independent of mass. Then if you take the charge of proton is 1. Charge of deuteron can take, and by seeing this radius which is having less charge will have maximum radius. Which is having less charge. Proton means H11, deuteron means H21, alpha particle means He24. So this is how you can calculate. Which is having less charge will have more radius. So these are the conditions. You can take this and you can answer this. This I am giving you as assignment. And based on the same concept, last year CET they asked, I think they given that the same velocity they have taken. Which one will have highest radius? They can ask which one will have highest kinetic energy also. Kinetic energy formula is q square b square r square by m. So kinetic energy is proportional to r square. So like that they can question based on this concept. And next topic what I want to study is moving charges and magnetism is Biot-Savart law. Biot-Savart law states that Biot-Savart law states that if you take a wire having current carrying wire of carrying current I, then if you point. For that, for finding direction, we have right-hand formula. You have to hold the wire in the direction of current. Then magnetic field, curved fingers will do the magnetic field. So here at this point P, magnetic field is into. But we don't know what is the magnitude of magnetic field, how much magnetic field is there. So for that reason, we can take the formula dB is equal to mu naught by 4 pi ideal sin theta by r square. Ideal sin theta by r square. This is the formula of Weier's. You have to take a small element and by using this formula we can find the d value. And sin theta is the angle between dl bar and r bar. If you write in vector form, this is can be written as mu naught by 4 pi I dl bar cross r bar. dl bar cross r bar. Therefore, theta is angle between dl bar and r bar. dl bar and r bar. So by using Weier's law, we can find magnetic field at the center of the circular coil. We can find a magnetic field at the center of the circular coil. Let us take a circular coil carrying current I in this direction. If you want magnetic field at center, go. Radius is r. Radius is r. For that, what you have to do? You have to select a small element of length dl. The distance of the r is the distance of the element from that point. Distance of the element of that point, that is r. Then theta is angle between dl bar. This is the direction of dl bar. Tangent. dl bar and r bar. R is nothing but radius. So theta is 90 degrees. Theta is 90 degrees. Therefore, we can find magnetic field B is equal to. We can find magnetic field B is equal to. Magnetic field B is equal to dB is equal to mu naught by 4 pi IDL by r square. And dl is, in this if you go for integration, everything is constant except dl. Mu naught by 4 pi I integral of dl by r square. So integral of dl is, maximum value of dl is nothing but 2 pi r. Therefore, you can write this as mu naught by 4 pi I into 2 pi r by r square. R and square will get cancelled. 2 pi and pi, so 2 times will get cancelled. It is mu naught I by 2r. Mu naught I by 2r. So this is how we apply the magnetic field. Weier's law. And by using Weier's law, you can find another formula. This is magnetic field at the center. Magnetic field at the axial line is BA is equal to mu naught N r square by 2 into x square plus r square. X square plus r square whole power 3 by 2. Where x is the distance from the axis. Suppose there is a wire carrying current like this. At a distance x from the center of the wire on the axial line, we can find the magnetic field. Magnetic field is equal to mu naught N r square by 2 into x square plus r square whole power 3 by 2. If you put x is equal to 0, you will get magnetic field at the center. Suppose this is the wire at the distance. For this derivation is there, that is already given in our videos. You can go back to our videos which are there for moving charges and magnetism. If you want the derivation part of this, I explain very clearly. And these are the two formulas you can get by using Weier's law. Similarly, for semicircle also you can calculate. You can calculate for semicircle also. Magnetic field due to semicircle. Magnetic field due to semicircle you can calculate by using Weier's law. Magnetic field due to semicircle is mu naught I by 4r because it is arc of the circle. Suppose if there is an arc making an angle theta at the center, theta by 4 pi r. For a circle, theta will be 2 pi r. For a semicircle, theta will be pi r. Suppose if there any arc is there and theta should be taken in radians. Theta should be radians. Theta should be radians. This is about by using Bayes-Savart law, all these formulas we can get. And before solving problems on Bayes-Savart law, we should know Ampere's law also, because problems will be included with Ampere's law. So for that reason, let us discuss Ampere's law and then we will see one or two sample questions based on Ampere's law and Bayes-Savart law. Ampere's law. Ampere's law is similar to Gauss law. What Ampere's law says is, suppose there is a line, a closed line having currents I1, I2 and I3, having currents I1, I2 and I3, then line integral, that is b bar dot dl, is equal to mu naught I inside. Mu naught I inside. That means you have to draw one line, just similar to Gauss law. If you draw one line, mu naught b bar dot dl is equal to mu naught into current inside. And next is, by using this Ampere's rule, we can find magnetic field due to an infinitely long wire. Suppose there is an infinitely long wire of carrying current I. Around this wire, you draw one line. You draw one line integral, which is b into 2 pi r. The maximum value of that line integral will be b into 2 pi r is equal to mu naught I. Suppose I want magnetic field at a distance r. Let that r will cross one circle. Let that r will cross one circle. B into 2 pi r is equal to mu naught I. B is equal to mu naught I by 2 pi r. Therefore, magnetic field due to an infinitely long wire, magnetic field due to an infinitely long wire at a distance r from its center is mu naught I by 2 pi r, where r is the distance. So what are the formulas so far I was studying? Just we list that formulas and we can close this session. So first formula I studied by using Bayes-Savart law is magnetic field in the center of a circular coil is equal to mu naught Ni, contains n turns, mu naught Ni by 2r. And magnetic field at the center of a semicircle is mu naught Ni by 4r. Magnetic field at the center of an arc which is making an angle theta at the center is mu naught Ni theta by 4 pi r, where theta is in radians. Next, magnetic field due to a circular coil on its axis at a distance x, that is mu naught Ni r square by 2 into x square plus r square whole power 3 by 2. Next, magnetic field due to an infinitely long wire, that is mu naught I by 2 pi r, mu naught I by 2 pi r. So these are the distance r from its axis, that is mu naught I by 2 pi r. So these are all the formulas what you are studying Bayes-Savart law. And in the next session, we will solve some problems based on Bayes-Savart law and Ampere's law. Thank you everyone for joining.